the achievements of mathematics is being able to take real data and make sense of it. And one of the things that they do is they try to find the central tendency. They try to find the spread. And all we're going to look at today are those two, the spread and the central tendency. But let's talk fishing. How many fishermen are there in here? Yeah? And what's your favorite fish to catch, Connor? Walleye. How about you? Pike, yes. Walleye. Anybody like bass? They don't taste good, but boy, are they fun to catch. Yeah, but I kind of agree. Well, imagine a lake that you're trying to find out the fish population. There's two ways that you can find the fish population. What's one of them? That's right. You can take a little bit of dynamite works, poison works, and watch them belly up. Quick little story. I had a friend when I was doing Cub Scouting with my son. We went to his house in do you know where St. Bonnie is? There's a house development. There were houses everywhere, and there's this little pond. And he said, we should go fishing. And I said, where are we going to go fishing? Oh, just behind my house. Okay, so we had all these little kids, first graders, and they had their little fishing poles, and we went around this little pond. And no kidding, they were hauling out bluegills that are like 2-3 pounds. I mean, I don't know if 3 pounds, but they were big. They were huge things. And what they'd done is he stocked it about 5 in the middle of the night, stocked with some little sunnies and bluegills, and there were no predators, and they just for 5 years just got bigger and bigger and bigger. Well, his wife didn't like the fact that they kind of stunk up the pond a little bit, so the next year when we were going to do it, we fished, and there weren't any fish. I said, what happened? And he said, well, my wife convinced me that we should treat the pond so it didn't stink so much. And so they treated it, and every bluegill that was in there was just killed. And so there was dead, belly-up fish everywhere. But he could calculate the population size of the pond by counting the dead bodies. And there were like 340, I think he said, which is so sad. And then I don't think he ever stocked it again. But population, that's one way. There's another way, and that's to take a sample size and go in one corner, like a fourth of the lake, and see how many fish you can get on that little corner, which doesn't sound very accurate, does it? I mean, where are these fish coming from, and so on. But the sample size is a subset, and if you say, oh, this is a fourth of the lake, I'll multiply by 4 and get an estimate. What you need to know about this is something they call the degrees of freedom of the population. If you absolutely know how many fish there are, there's no randomness in your selection process, so you can use the total of the population equal to n. But if you're doing a sample, the randomness of selecting, they use a total sample of n minus 1. And I don't know if that's a very good explanation, but the reason they do that is that it's still a random selection. So we don't know what the population is exactly. And so all the way down to the last one, it's still uncertain of that value. We'll come back to that. Central tendency. So if we're looking at population, you just add up how many you have and divide by n. So that would be your average. So if you were looking at weights, you'd add up all the weights, weight 1, weight 2, weight 3, and you divide by 3, and you'd find the average weight. Okay. The mean, population mean, we use the symbol mu. Have you seen that one before? Mu? Yeah. If you can't remember it, this is mu. Mu. All right. It's lame, but that's how I remember it. And so next, you're going to, so we've got sample mean as x. And there's usually a little bar above that for sample mean. Mode is the most frequently appearing item. I think of ice creams. Pie a la mode has ice cream on it. And so you stack up a whole bunch of ice cream, and you're looking at the mode as the most frequent item. I don't know how that really connects, but I love ice cream. And then median is a little easier. Median is easier when you're looking at the road. Where's the median of the road? In the middle of the road. So it's the middle value, and you always organize from smallest to largest before you find the median. And when you go from small to large, then the middle value, in this case, it's the average of these two, 8, is your median. So if you do get 2 in your middle, you do have to do the average of those. That's nice. Easy. Well, then comes the part you don't like, the spread. The spread is the deviation from that center. And so how do you calculate it? How do you calculate the standard deviation? And what is this thing? And what is this? Well, this with not squared is called the standard deviation. And when it's squared, we call it the variance. And it just helps you find, variance helps you find the standard deviation. Formula is super easy for variance. It's the sum of I going from 1 to n of xi, whatever your value is, minus the mean, squared over, now if you're looking at a population, it's n. If it's a sample, it's n minus 1. And that's your variance. That formula doesn't make any sense, does it? Is this what freaked you out last year? Let's unfreak you out right now. I have the numbers 1 through 5 listed here, A, B, C, and D. And what I want you to find is what the middle or the average is of this. And we're going to call this a population because I don't want you dividing by n minus 1. Just divide by n. We're going to call these populations. You're going to find the variance, and then you're going to find the standard deviation. I'll do the first one with you. To find the average of that population, you're going to go 1 plus 2 plus 3 plus 4 plus 5, which is what? 6, 12, 15 over 5. What is that? 3. Well, that's easy. When you find the variance, all you're going to do is you're going to add up 1 minus 3 squared, then 2 minus 3 squared, then 3 minus 3 squared, and 4 minus 3 squared, and then lastly 5 minus 3 squared. And you're going to divide by, we had 1, 2, 3, 4, 5. By the way, what is 4 plus 1 plus 0 plus 1 plus 4? What's that equal to? 10. So this is going to be 10 over 2. So this is just going to be 10 over 2 is, 10 over 5 is 2. Yes, thank you. So what's the standard deviation? Square root of 2, yeah, or 1 point. Yeah. That part, is that okay? Yeah. Yep. Yep. So go ahead, and if things are going great, go ahead and do B, C, and D. Go ahead and try that right now. I'm going to explain that step. So this is xi minus average squared, and we're going to add up all of these from beginning to end. So I take that first one, which was a 1. I subtract the average, which was 3, and square it. That takes care of 1. Then I take 2, which is my next one, subtract 3, the average, and square it, and go all the way to 5. So for this one, did you get an average of 2, and this one you got an average of 4, and this one you got an average of 3? Does that sound about right? Now, before we do the spread, Let's use some logic here. Take a look at 1 through 5. Can you see why the average was 3 just by looking at it? Do these seem pretty spread apart, this 1 through 5? Well, pretty spread apart compared to this one. They're more clumped together, aren't they, with 1? Now, this average we get is 2. Can you see why it's probably not 3 because there's more 1s? And can you see why this one's 4? There's more 5s. That's going to drive that up a little bit. How do you think these two spreads are going to be? They're the same, aren't they? Just because I've just put the 3 1s, changed it with 3 5s. I would guess that these two are going to be the same. Will these two be the same as this one? Probably not. Well, you can definitely see where the center is 3, and I don't think this one is going to be spread as much as these two. Well, let's see. So we're going to go 1 minus 2 squared, and there's going to be 3 of them, right? Then 2 minus 2 squared is 0, and then I'm going to have 5 minus 2 squared is 9. So this is going to be 3 plus 9 is 12, right? 12 over 5 is my, did anybody else get 12 over 5? Yep. So this is 12 over 5, or is that, what is that, 1.4? And I like the 1.4 because you can see it is smaller than this. Oh, was it 2.4? Why did I miss that? Oh, 2.4, yeah. Whoops. Okay, this is 2.4, so it is bigger, isn't it? It is a little larger than this one. Yeah, you can see that these are spread out. This 5, and there's more 1s spread out from the 5, so yeah, that's bigger. And then this will also be 2.4, square root of 2.4. How about this one? I don't think this one has as much spread. This one's going to be an average of 3, so you're going to have 2 minus 3 squared plus 0 plus 0 plus 0 plus 4 minus 3 squared. This is going to be 1, and this is going to be 1. Oh, this is only going to be 2 over 5, or 0.4. Is that what you got? And so this will be the square root of 0.4. So does this kind of make sense that you're looking at these spreads, different spreads for these, different variances and standard deviations? Okay, real quick, the cumulative frequency table is just, you just add these up. So this is 1. This one's going to have a total of 3. This one's going to have a total of 7. This one's going to have a total of 9. And so the idea here, did I add those up? 3, 7, 8, 9. So then when you graph those, you'll get 1, 1, 2, and what happens with those is you're going to get this kind of leveling off at 9. For quartiles, that's, you find the middle value again, and when you find that middle value, it goes here. You go the middle of the middle. This is your 1/4, 25%. For tomorrow, see if you can get just the homework ones at the end.